Hello, everyone. Today, I want to talk about petroleum intelligence systems versus petroleum data analytics and provide you guys some differences and the descriptions that used in these two concepts and technologies. My name is Hossein Izadi. I'm a PhD student in petroleum engineering at the University of Alberta. I have 10 years experiences in the application of machine learning and machine vision in petroleum industry and also in mining engineering, in neurosciences, medical imaging, and also handwriting recognition. I have asserted one patent, published 12 journal and 11 conference papers, and also I have developed 6 intelligent research-based software for the industry so far. Okay, Petroleum Intelligent System (PIS). I just use this abbreviation. It doesn't mean that you can search it on Google and give and find many information about this. I just use these abbreviations for, making the presentation easier for comparing with the Petroleum Data Analytics that you can find its abbreviation on Google that it's PDA, Petroleum Data Analytics. And so I just use the abbreviation for making the comparison easier for the conclusion part. Petroleum Intelligent System is about intelligent programming. It's beyond that programming. It's harder than programming. But you actually you have to program intelligently. You have to teach the computer for some basically workflows. In petroleum intelligence systems, you have to make a workflow intelligent. Okay, and it's mostly unsupervised. It doesn't mean that supervised algorithms cannot be used for petroleum intelligence systems, but mostly they are unsupervised. They are developed for decision making. When you teach a computer to think and act like a human expert and help the human expert and as an assistive technology for increasing the speeds of interpretations or increasing the speeds of decision making. This is petroleum intelligence systems. And it's always under the human expert supervision. The final results, the progress of developing the system, everything is based on the human expert supervision. And the both machine learning and machine vision can be used in petroleum intelligence systems. Let's go through some real examples for better understanding. This is an example of using machine vision in subsurface engineering. This is one of my papers that this year, 2020, published in the Journal of Engineering Applications of Artificial Intelligence. In this paper, we used an incremental clustering algorithm for mineral segmentation, basically intelligent mineral segmentation in thin sections. And none of algorithms developed in computer science community for image segmentation cannot segment these images. Just see the image here. Many color changing due to something like the different angle of cuttings, the alteration, everything can be the cause of this color changing. Many color changing we have in this image here, and none of the algorithms, none of them, based on to the best of my knowledge, none of the algorithms that developed in the computer science community cannot segment these thin sections for providing a perfect segmentation map. The algorithms in the computer science can identify maybe these color changing as a unique mineral, and they cannot find out that all these color changing is corresponding for a unique mineral species. And my algorithm can recognize that all of these color changing are related to one mineral species. Not It's not for four or three or five mineral species. And this paper and this algorithm for intelligent mineral segmentation, especially altered mineral segmentation with uh, a very large color changing and very large amount of alteration. This algorithm is the best algorithm in the literature that can deal with the images that contain a huge amount of uncertainty and noises. These images that you can see in this slide, especially some of them, basically is somehow noise for computer science community. Uh, the machine learning experts that graduated from computer science community cannot work with these signals and data and images based on their description. All of these are noises, and I'm telling you guys this point based on my experiences for working with the guys in McGill University and also many other well-known university in the world. And when I worked with the guys that graduated in computer science community and computer science, computer engineering, they when they saw my images like this and the signals that I gathered from the subsurface observations, they panicked really because they don't have any idea how they can come up with some solutions with to these, you know, very large amount of noises in the database. And this is one of the contributions that petroleum intelligence systems can give us for solving the problems intelligently. This is another example that we used, the pixel values in RGB and HSI color spaces after the segmentation for intelligent mineral identification using the neural network. I had a very large database of pixels, and I trained my network for uh, identifying and predicting the name of minerals based on the thin sections. As you can see here, our software IM is intelligent mineral segmentation and identification, uh, uses pixel values of the segmented minerals for identifying the name of the minerals, and finally the probable target rock that maybe this thin section mounted and created from that rock. And also you can find this paper in Computers and Geosciences Journal. Another work that I want to share with you guys as an example of petroleum intelligence system is PSD class, intelligent PSD clustering. PSD particle size distribution of oil sand reservoirs here in Alberta. We have oil sand that some sand control design should be developed for the wells that produces oil here in Alberta. During the sand control design, we need some specifications about the size of grains in the well site. And one of the characteristics that we use for this interpretation is PSD particle size distributions of the data that we gather in the field. Uh, Particle size are very important for designing the sand control design. It's important for the workflow of designing the sand control. Uh, and I developed an intelligent algorithm for clustering these PSDs that obtained from the field. And based on these cluster data, the workflow for sand control design will be very easier and more reliable. It helps the human expert for coming up with a better interpretation and a better design for the sound control. And this is the contribution of petroleum intelligence system. It helps the human expert and it increases the speed of the workflow. It makes the workflow intelligent. It makes the whole workflow intelligent. In subsurface, in the data that we obtained from the subsurface, we don't have any idea how many clusters we have in our database. So we have to develop a clustering algorithm that doesn't need the number of clusters as an input data, like KNN and, for example, k-means. These algorithms that already developed in the computer science, they cannot be used in our, works in our industry, because before the data processing, we don't have any idea how many clusters we may have in our database. So this is another example of petroleum intelligence systems that helps the human expert and makes a workflow intelligent and increases the speed of a process. And another thing, and the last example for petroleum intelligence system stands for the permeability estimation. I used a correlation, a base correlation based on the literature between permeability and the values that we provided and gathered and measured based on particle size distribution. And I used genetic binary algorithms, genetic binary particle swarm optimization algorithm as an intelligent algorithm for optimizing the coefficients A, B, and C to minimize the real permeability measurements with the predicted permeability using this correlation. I didn't use neural network for training a model and predict the values of permeability, because it was wrong if I used a neural network for my prediction, because I didn't have enough data. I didn't have enough data for training a model based on neural network. How many data I need uh, for training a neural network for probability estimation? It's $1 million question. It's based on the heterogeneity in your field. It's based on your field. It's based on the nature of the geology of the field under the study. It depends of many things, guys. But in this field, in this case, I didn't have enough data. So I just used a basic correlation and optimized the coefficients using intelligence system. I didn't use neural network for prediction. It's very important thing. However, in petroleum data analytics, PDA, that Professor Shahab Mohabbat is the pioneer of developing PDA and using PDA in the industry. At the first step, PDA needs a very big and large database. If you don't have such a big database, based on Professor Mohammed's comment, don't use PDA if you don't have such a big database. So the first thing for using PDA is a very large database. How large database? Your database should be large enough that you can claim that your database is completely representative of your reservoir or your field. It should be large enough that you can claim that your database is representative of your reservoir. And if you don't have such a big database, don't use PDA or intelligence systems for prediction based on neural network. You can see my previous video entitled Is Artificial Neural Network a Reliable Tool for Prediction in Subsurface Engineering? And I explained the reason that you can't use a single well information and data for predicting something in another well just based on the information of one well. It's a joke, really. PDA uses data as everything. you know PDA uses data for making the model, for workflow, for decision making. Everything in PDA is based on data. Everything is based on data. So even the physics is created using data. The data creates the physics in PDA. Big why? Because we have very large database. We have a representative database. So we can rely on the data. We have very large database. And PDA uses hard data. Why? Because we have very large database. There is no simulation. There is no need for simulation for creating soft data. We have everything in every location. We have very large database. And so, because we have very large database and we just uses hard data, the PDA avoids assumptions, simplifications, and everything like this because it has very large database. You can see some applications of PDA here. I don't want to go through all of them in this lecture. It's beyond of the goal and scope of this lecture, but I just put it here for you guys that you can see it has many applications as long as you have very large database. And this is another example that based on a PDA, some reasonable interpretation for chain analytics was provided by Professor Mohabbet, and using a statistical model, it failed. And this is the contribution of one of an example of contribution of PDA. You can go through it in Professor Mohabbet papers and books. And conclusion part is the most important part of this lecture. PIS, Petroleum Intelligent System, and PDA, Petroleum Data Analytics, they both are what make the hardware smart. They both are explainable AI. In the both, you can find out why you have such a result. You know, none of them, they both are explainable. None of them are black boxes. They both are completely clear, the workflow. In PIS, due to the differences of tasks and also the lack of existing large number of data, you teach and train the computer to act and decide like human expert. It's very important. In PIS, we teach the computer, we train the computer because we don't have very large database to rely on for creating the physics, for creating the assumptions. Another thing is that the differences of tasks. I mean that in PIS we have different tasks. The tasks that cover by PIS is larger than the tasks that PDA can cover. This is because in PIS we can also use 2D or 3D signals as images or another thing. But in PDA, we just can use 1D signals as digits, values for making our interpretations or making our model or everything. However, in PDA, everything is based on the data. Everything in PDA is based on the data. The data itself creates everything. So it has two messages. The first one is we have to gather and collect a very large database. And the second message is that the database should be correct. I mean, the uncertainty in the data should be low. The data should be already interpreted. The data should be corrected. For example, if you are using log database, well log database, an expert must correct the values of the logs before inputting the values to the PDA, because everything is based on the data. The data should be correct and reliable. In PIS, another thing that I would like to mention, how much the data should be corrected and how much the amount of uncertainty in the data should be reduced. It's a very good question. It's based on the field that you are working on. It's based on the complexity of the geology in the field. It's based on the even the developer that is hired for for developing the PDA or PIS models and systems for solving the problem. It depends on many things, but just keep it in your mind that intelligent systems can reduce the noises itself during the training. So it's somehow tricky and it's beyond of the scope of this presentation. But just for let you know, guys, um, you have to control the amount of uncertainty in your database. In PIS, you can work using low number of data, but in PDA, you have to make sure that your database is large enough that you can claim that this database is representative enough of my reservoir under the study. If don't, avoid it. In PIS, machine vision plays an important role, as I showed you guys some examples. But in PDA, machine vision cannot be used. It doesn't mean that PDA is something, less advantage than PIS. It doesn't mean that. PDA doesn't use the machine vision. It doesn't use that. Just for comparing the differences between these two technologies. And finally, down the road, they both are under the human expert supervision. The results should be confirmed by the human expert supervision. Thank you guys for your time for watching this video. Please let me know your comments and please see the video on the channel. It will be appreciated. Thank you so much. Have a nice day.